Hey guys, today we're going to take a look at clearing fractions and decimals from equations. So I want you to pause the video and copy the steps down to solving equations. Before we actually get into clearing fractions and decimals, I want to review a couple of basic ideas. So if I have, let's look at fractions first. So let's say I have 1/3. When I take a look at this, I notice that my denominator or bottom number is 3. If I multiply this equation by the number that's on the bottom, sorry about that, then what happens is 3 times 1 is 3, and then 3 divided by 3 is 1. So really what happens is this number cancels the denominator and I'm left with what's on top. Take a look at something like this. Let's say I have 2/3 and I multiply it by 3. My number I'm multiplying by and 3 cancel and I'm left with 2. Let's look at one more example. Let's say I take that same fraction, 2/3, and I multiply it by 6. Well, the 6 and the 3 don't cancel, but I know that there are 2 3s in 6. So watch this. Now I can say 2 times 2 is 4. So 2/3 times 6 gives me 4. So that's a little bit of background on how to deal with fractions. Now let's take a look at multiplying decimals. So let's say I have 0.4 or 4/10. And it's important that you understand how to read it properly because that's how you decide what to multiply by in our lesson today. So this is 4/10. So if I multiply this by 4/10, I apologize. If I multiply this by 10, I have 1 0. That's going to move my decimal over one space to give me 4. Let's try something else. If I take that same number and multiply it by 100, there are 2 zeros. What happens is I move my decimal 2 spaces and I end up with 40. Let's try another one. Let's say I have this decimal. Well, to read that properly, it would be 15/100. So if I multiply this by 100, there are 2 zeros, so I move my decimal twice to get 15. So 15/100 times 100 gives me 15. Now let's take a look at what this means when we're solving equations. Let's look at the first example. So I have 1/5 times x plus 1 equals 3/10. Well, in order to clear a fraction from an equation, I have to find the common denominator. So I have 5 and 10. So my common denominator is going to be 10. So I'm going to multiply everything by 10, both sides, to clear out those fractions. So watch what happens. I'm going to do the right side first. It's a little bit easier. 3/10 times 10, well, that cancels and leaves me with 3. Now let's do the left side. This is really the distributive property, but it just looks a little different. So 10 times 1/5, well, watch this. How many 5s can I get out of 10? I get 2. So 2 times 1 is 2x. And remember to multiply everything by 10. 10 times 1 is 10. Now this looks just like the equations that we're used to. The next step is the distributive property. I don't see it. Then, do I have like terms? No. So now I'm simply going to isolate the variable using inverse operations. Find your variable. The opposite of plus 10 is minus 10. So I'm left with 2x equals -7. I still have a number with my variable, a coefficient, so the opposite of times 2 is divided by 2. So x equals -7/2. So if you have a fraction, just leave your answer as a simplified fraction. And this can't be reduced anymore. also leave it as an improper if it's improper. I'll explain why in a couple of weeks. All right, so our goal is to clear those fractions and decimals to make our equations look like what we're used to. So let's try another one. Let's say we have x divided by 6 plus 2/3 equals 5/4. Well, every single one of those terms has a fraction. So I look at my denominators and I notice I have 6, 3, and 4. Every single one of those is a factor of 12. So I'm going to multiply both sides by 12. So now I'm going to split my equation at the equal sign. So let's do this. How many times does 6 go into 12? It goes in there twice, so I end up with 2x. Now let's do the other one. How many times does 3 go into 12? Well, it goes in there 4 times, so 4 times 2 is 8. Now let's do the other side. How many times does 4 go into 12? 3 times, and 5 times 3 is 15. Now I have a simple two-step equation that I can work on. So let's isolate the variable by subtracting 8 from both sides. Use your inverse operations. 2x equals 15 minus 8 is 7. I still have a coefficient or a number hanging on to my variable, so I'm going to divide both sides by 2. So x equals 7/2. That is my solution. Now let's take a look at some decimals. How are we going to clear these decimals? So I have 3/100 x equals 6/10 x. Go ahead and split your equation at the equal sign. Now, if you'll remember earlier, we talked about reading this properly to decide what we're going to multiply by. So I have hundredths on this side, and I have tenths on this side. So I want to go with my my bigger number that I'm going to multiply by. So since this is hundredths on the left, I want to multiply both sides by 100. So 3/100 times 100, remember that's 2 moves of the decimal, so that gives me 3x. And then 6/10 times 100, again, that's 2 decimal jumps. 1, 2 equals 60. Now, all I need to do is isolate the variable by dividing. So the opposite of times 3 is to divide both sides by 3. So x equals 20. So let me say this. You can work with the fractions if you want to. You can work with the decimals if you want to. This is just a way, if you don't have a calculator handy, that you can clear it up and make it a little more simple to work with. So let's try a couple more examples. Example 4. So I have 2/100 minus 5/100 x equals negative 68/100 plus 3/10 x. So first let's split our equation at the equal sign. All right, so I'm going to read these. 2/100, 5/100, 68/100, 3/10. So the biggest decimal that I hear, or the biggest number I hear, is hundredths. So I'm going to multiply everything by 100. Both sides. I don't know if you've noticed it or not, but this is kind of like the distributive property. It's not kind of, it is. When we're multiplying this through, we want to make sure everything inside the parentheses gets multiplied by that number. So let's go ahead and do that. 2/100 times 100 is 2. 5/100 times 100 is 5. Keep your x, remember your x. Negative 68/100 times 100, that's 2 jumps, equals negative 68. And last but not least, 3/10 times 100, remember that's 2 jumps, so I've got to fill in that 0. So it's a plus 30x. Now it looks like what we've been doing. So I don't see the distributive property. I don't see like terms on each side. I do see that I need to get isolate the variable. And I also notice there are variables on both sides, so I'm going to move that 30x over with the negative 5x. The opposite of negative 30x, the opposite of plus 30x is negative 30x. So I have 2 minus 35x equals negative 68, and that cancels. So I still need to do inverse operations to isolate the variable. So I'm going to, this is a plus 2, so I'm going to subtract 2 from both sides. So I'm left with negative 35x equals, same signs, add the numbers, keep the sign. Yep, that's right. I still need to isolate that variable, so I use the opposite of times negative 35, which is to divide both sides by negative 35. So x equals, and same signs positive, 70 divided by 35 is 2. So the solution to this equation is 2. And our last example. So we have 1/3 times the quantity x plus 4 equals 1/2 times 3x plus 5. Now, I know that I've jumped from fractions to decimals and back to fractions, but I want to show you something that has distributive property on both sides, how you can clear that. So I notice I have 1/3 on the left and 1/2 on the right. So first I want to come up with a common denominator to multiply by. And if you can't come up with one quickly, just multiply them together. 3 times 2 is 6. So I'm going to multiply both sides by 6. But I need you to hear this. That only affects the numbers outside of the parentheses. This x plus 4 and this 3x plus 5, leave them alone. So now 6 times 1/3, there are 2 3s in 6, and 2 times 1 is 2. There are 3 2s in 6, and 3 times 1 is 3. Now this looks like what we've been doing. So step 1, or actually now it's step 2, but first I'm going to do the distributive property. 2 times 1x is 2x. 2 times 4 is positive 8. 3 times 3x is 9x. And 3 times 5 is positive 15. I don't see like terms on each side. So now I want to isolate the variable. And I do notice there are variables on both sides, so I want to start by moving my letters to the left. Again, that's a matter of preference for me. The opposite of plus 9x is minus 9x. 2x minus 9x is negative 7x. Plus 8 equals 9x minus 9x cancels, and I'm left with 15. Let's keep doing our inverse operations. First we add or subtract. So the opposite of plus 8 is minus 8. Left with negative 7x equals 15 minus 8 is 7. And the last step to isolate is going to be to divide both sides by negative 7. So x equals negative 1.